Good evening. My name is Fabian Arun Panaite, and along with Professor Monica Leba, Remu Sibishanu, and Marius Leonard Olar from the University of Petroșani, we'll be presenting the paper called Motion Sensors-Based Human Arm Pose Estimation. The presentation contents are 1. Introduction, where we'll expose the main purpose of our prototype. 2. The experiment design, to show the basic design and data direction of the system. 3. Electronic blueprint, to illustrate and explain the connections. 4. The simulation, starting from the recorded motion and gradually moving towards the MATLAB simulation based on kinematics. And 5. Conclusions. Introduction. This proposed prototype has 3 MPU 6050 IMU sensors connected to an Arduino Uno development board through a TCA 9548A multiplexing chip, which transmits the captured motion data to a computer that uses MATLAB to post-process the data and simulate the motion in a 3D environment. Experiment design. This is the motion capture prototype design. We've envisioned the design in order to position the sensors in the middle of the segments between the articulations of the arm. In relation to the functioning of the sensors, each sensor has its own 3-axis orientation, thus resulting the angle of each segment of the arm. Here we have the motion capture prototype hardware release that has the 3 IMU sensors with their respective positions, with the specificity that the TCA and Arduino board are connected to a PC via USB. What the system does is that it acquires the position data of the sensors, multiplexes it in the TCA, sends it through the Arduino board's I2C to a COM port on the PC. The PC acquires the data from the Arduino, and the serial port sends it into MATLAB. Electronic blueprint. The connections from the IMU sensors to the TCA multiplexer to the Arduino board. The connections are simple because the positive 5 volts and the ground wires are in parallel and go to each sensor and to the TCA, while the data wires, SDA and serial clock, have dedicated input channels on the TCA multiplexer for each IMU sensor and has only one output for the Arduino Uno board. The simulation, recorded motion. This is a sequential reconstruction of the upper limb movement in the action of grabbing a cup and drinking. The first photo depicts the position where all the sensors have default values, and the next 4 are showing the positions for the human arm movement. In this series of graphs, there are the acquired motion angles from the 3 IMU sensors with their respective pitch, roll, and yaw. The 3D rendered arm simulation results. At the end of the presentation, I'll show you a video with its movements, while on the right side there are the angles for each articulation of the arm. As you can see, the elbow does not have an x-coordinate set because the elbow does not have a pitch. Direct kinematics. This is the elementary motion matrix from one articulation to the next, from the shoulder to the elbow, and from the elbow to the wrist. In the second matrix, it is the computed motion matrix from the shoulder to the wrist, where the first 3 columns represent the wrist orientation relative to the shoulder, and the last column gives us the wrist position relative to the shoulder. Now for the video. And here for the conclusions. The challenges this paper has responded to were first to prove the use of more than 2 MPU 6050 sensors with only one Arduino development board, and second to capture the motion of the human arm, which was acquired and processed in MATLAB. The next challenges that our future research may respond to is to enable a wireless connection between the motion capture system and the computer, and further ensuring the power reliability on a rechargeable battery. Thank you very much for your attention.